Welcome to this M1 video on resolving forces. So if I have, an object, say, on the floor or a table, let's draw it as a box here. So I've got this object, and unlike in the past now where we just had like a horizontal force or vertical forces, this time my force acts up at an angle, so F newtons, and that angle we'll call theta. Now, for us to make more use of this, in a problem, this force would drag the box along this way. It might not have enough force to lift the box up off the floor, but it would certainly probably have enough force to drag it along this way. And for us to find out, kind of what the acceleration is, or that work out the velocity at a certain point of dragging this along, we need to split this up into its components, its horizontal components and its vertical components. Because this box, this force F that's coming at an angle will have a force going horizontally and a force pulling it vertically. Now, for us to split F up into its horizontal force, if we look at that first of all, let's think of making this a triangle. So I'll make this just the AB. And what I can look at is cos theta is adjacent over hypotenuse. So this is the adjacent, the opposite, and the hypotenuse. So cos theta is AB over that force, capital F. So AB is F cos theta. Okay, so that gives me that horizontal component. Now, if I look at this vertical one, this is 90 minus theta, isn't it? This is the opposite, the adjacent, and the hypotenuse is the same. So this time I'd have cos 90 minus theta is the adjacent, let's call that AC, over the hypotenuse. So that's cos 90 minus theta is AC over F, and AC then is F cos 90 minus theta. Now, cos 90 minus theta is the same as sine theta. So AC then is F sine theta. Okay, and that therefore gives me my two ways of splitting my force up into its components. So, for example, if I had, I don't know, let's draw another force. Let's go, let's make this 10 newtons and 30 degrees. Okay, and I want to split this up into its horizontal and its vertical forces. So it's vertical forces this way and its horizontal forces this way. So its horizontal force now is going to be 10 cos 30. And its vertical force will be 10 sine 30. Okay? And it's not really just thinking of like cos is always the horizontal one and sine is always the vertical one. Cos is the one that you have the angle for. So it is horizontal in this case because we have that angle theta. And the sine one becomes from the 90 minus the angle, which is why it's the vertical one in this case. But if I was given a different angle, so for example, if I was given this angle here, then this vertical one would be, let's call this 15 newtons. This vertical one would be 15 cos 20, and this horizontal one would be 15 sine 20. So it's always cos of the angle that you know that it makes with either the vertical or the horizontal, and then the other one is sine, and that's where you're looking at the 90 minus angle. Okay, so this one makes 20 degrees with the vertical, so that's why it's 15 cos 20, and this angle here that it makes with the horizontal is the 90 minus that, which is why it's the sine. Okay, hopefully that makes sense to you. So the cos of the angle is the angle that you know that it makes with the generally the horizontal, but it could also make it with the vertical. And then sine for the other one, the one that's the 90 minus. Okay. So let's look at this in practice with some examples. Hopefully it'll all start making sense by the time we go through the examples. So find the component of the force in the I and J directions. So the I direction is this horizontal one and the J direction is this vertical one. And this is going to be 20 cos 30, which we can work out. Just 20 cos 30 in the calculator gives me 10 root 3 newtons. And this vertical one now will be 20 sine 30. Okay, and 20 sine 30 is 10 newtons. So this component of the 20 newtons means that this force is effectively acting at 10 root 3 newtons horizontally, which is around 17 newtons, and then 10 newtons vertically. So, you know, if you're pulling like a box, if the box is heavy enough, it won't lift off the ground by that 10 newtons. But if there's no friction, if it's on a smooth surface, it would move to the right. Okay, and you can see that's the kind of thing that happens in real life. Okay, so there's that example. Let's have a look at the next one. So here we have a box of mass 12 kilograms. All this is just shown in the diagram. A force of 15 newtons applied at an angle of 30 degrees. And the box accelerates horizontally along the floor. So it's not lifted up, it is going horizontally along the floor. Work out the acceleration of the box and calculate the normal reaction between the box and the floor. So let's start by splitting this 15 newtons up into its components. So this is going to be 15 cos 30, which I can work out. 15 cos 30 is roughly 13 newtons, but I'll actually leave it as 15 cos 30 for now, and vertically will be 15 sine 30. Okay, so looking at now A, we want F equals MA. Now that horizontal force is 15 cos 30. Its mass is 12 and A we want to find. And 15 cos 30 divided by 12 is 1.08 meters per second squared to three significant figures. So there's that one done. Now, we need to find the normal reaction between the box and the floor. It's obviously not lifting up off the floor. So that means that the normal reaction R plus this vertical force here, 15 sine 30, must be equal to the 12G force. So R equals 12G minus 15 sine 30, and that's 110.1 newtons. Sorry, there was an ambulance going past the house there in the background. So that is now how we do this example. And a lot of the ones we're going to look at today are just going to have single forces to split up into its components and then resolve. So in this case, in the second one, we were actually resolving vertically. And I probably should have put that down there. Okay, and this one, we were resolving horizontally. Okay, did forget to just mark that in. But anyway, let's have a look at another example. So here I have two forces, and what I can do is I can split these forces up into their components, their horizontal and vertical components. So, P will be split up into a horizontal and a vertically up component. Q will be a horizontal and vertically down component. And then I can resolve them. So the two horizontal ones I would add together, and the two vertical ones, because they're in opposite directions, I would subtract. And that would give me, a horizontal and a vertical one, which then I could find using, Pythagoras, what the magnitude is here, and then I can find that angle in there. But there is an easier way when we're looking at two forces, because to resolve them, we can use what's called the triangle law of vector addition. Okay, and to do this, I basically add my two vectors together. So if I think of Q is going down like this, and that is at 6 newtons, and then P goes off up there, and that's longer because that's at 15 newtons. And this force joining them together to complete the triangle, that will be the resultant. Okay, now if I continue Q down like this angle here is the angle between P and Q. This is P, this is like Q. So this angle here is 75 degrees, which makes this angle 105 degrees. And for later, we can work out that this is 45 degrees, and that would be a little theta to find there. But first we can go ahead and find out what R is. And to do that, we can use the cosine rule. So the cosine rule states that R squared is equal to 6 squared plus 15 squared minus 2 times 6 times 15 times cos 105, which is 307.6 to 1 decimal place, and square rooted is 17.5 newtons. And this is the three significant figures. Now, to find the angle, we can use the sine rule. So this angle over 15, so that'll be 45 plus theta over 15 is equal to 105 over R. Sorry, I missed out my sines. Sine 105 over r. And rearranging this, we get this to be 55.7 degrees. Therefore, theta is 10.7 degrees. Okay, so this is, the resultant of this is 17.5 newtons at 10.7 degrees above the horizontal. Okay, so that's resolving these two forces using the triangle law of vector addition. Okay, I think you'll agree this is quite straightforward. Now I'll show you how you would do it if you split it up into the components. So if we're splitting it up into the components, P is 15 newtons and Q is 6 newtons. So going horizontally this way, we've got 15 cos 30. And vertically, we've got 15 sine 30. Then for Q, we've got 6 cos 45, and downwards we've got 6 sine 45. Okay, so going to the right, we've got 15 cos 30 plus 6 cos 45, and I know it's going to be up 15 sine 30 minus 6 sine 45. So those are my kind of resolved components. And this is 17.2 to 3 significant figures. And this one is 3.26 to 3 significant figures. And I can put that, in a triangle. 17.2 and 3.26. That's r and that's theta. So it's quite straightforward then from here, r squared is that 17.2 squared plus 3.26 squared, and then square rooted, and of course using my full values, and I get 17.5 newtons, and then tan theta is 3.26 over 17.2. And that's 10.7 degrees. Okay, so you get the same answers if you split it up into its components. It's arguably a little bit quicker, I think, using the triangle law, but I think you can see here you can do it pretty much just as quick with resolving as well. Okay, so there's nothing too difficult about this. Also, if I got these the wrong way around, this would have been minus, which would have meant then it does go downwards. Okay, so you can split up into its components and then combine into a single vector and find the angle of that vector and do it that way. Okay, but the other way is just to give you an additional way in which you can do it. It's totally up to you at the end of the day. Now let's look at the next example. So we've got 3 forces are acting upon a particle as shown here. Given that the particle is in equilibrium, calculate the magnitude of P. So if it's in equilibrium, it means that all of these forces are cancelling out. So let's just make a copy of the diagram and bring it down here. So let's first split this 151 up. So we've got this going to the right, and it's 150 cos 30 degrees. and then up 150 sine 30 degrees. Now I'll split the 110 one up and I'll do this in red. So horizontally 110 cos 45 degrees and vertically 110 sine 45 degrees. And then in purple for the P, so I'm assuming that P is drawn in the right place, but it might not be. The signs will tell us that though. So P cos theta and P sine theta. Oh, I've written 30 there, theta. So that's what I've got to work with. So let's first resolve horizontally. Okay, so everything on the left will be 150 cos 30, and then on the right we've got 110 cos 45 plus P cos theta. Okay, so that gives me one equation with two unknowns. Resolving vertically, I get 150 sine 30 plus 110 sine 45 equals P sine theta. So that gives me two equations now with two unknowns. So from equation 1, P cos theta, now that's going to be equal to 150 cos 30 minus 110 cos 45. And that's going to be 52.1 to three significant figures, but I'll save that in my calculator in the A section. And then P sine theta is 150 sine 30 plus 110 sine 45. And that's going to be 152.8. And again, I'll store that in my calculator as B. Now, if I do one of these divided by the other one, so P sine theta divided by P cos theta, that'll be 152.8 over 52.1. Now the P's will cancel, and the sine over cos gives me tan. Okay, so 2.93. So theta is shift tan 71.2 degrees to three significant figures. And I'll save that as C. Now I need to find out what P is. I can substitute this back into any one of these equations. I'll substitute it into this one. Okay, so 52.1 divided by cos C, so I'll do P equals 52.1 over cos of 71.2, and that is 161.4 newtons to one decimal place. I'll do it there. Okay, and that is then how we resolve three vectors. If they're in equilibrium, the horizontal vectors components must be equal and the vertical vector components must be equal. Okay, and in this case, two unknowns, and we got two equations. So hopefully you're able to follow that. Nothing too challenging, I don't think. But I think it's time to pretty much have a go yourself. So if you are yet to subscribe, don't forget, hit that subscribe button. Hit the like button if you're finding this video useful so far, and if you're willing and able to help me out financially, hit that join button. Otherwise, let's look at the questions. So I got 5 questions for you today. Question 1 is just like a little warm-up question that I've done a bit like one of the first examples. And then questions 2, 3, 4 and 5 are past paper questions that I found on this kind of concept. So have a go at those. So you'll need to pause the video now. Okay, I'll go on to questions 4 and 5. Here's 4 and 5, so pause the video now. Okay, hopefully you are back and ready to look at the answers. So let's jump into question 1. So here we have it. We will split the 5 Newton force up into 2 components. So 5 cos 30 and 5 sine 30 there. So part A is F equals MA. We are resolving horizontally. The force is 5 cos 30. The mass is 2 and A is what we want to find. And that's 2.17 meters per second. I've rounded to 3 significant figures. So obviously just check what you've rounded to there. Right, work out the normal reaction. So we're going to resolve vertically in this case. So R plus 5 sine 30 is equal to 2G. So R is going to be 2G minus 5 sine 30. And that's going to be 17.1 newtons. Nice and easy warm-up question there. Let's jump into number 2. So we've got a force P applied to a box of 10 kilograms, causing the box to accelerate at 2 meters per second along a smooth horizontal plane. So remember, I do like to draw out what's happening. So we've got a box, so it's got a downward force of this box of 10G, and an upward normal reaction. The force is applied at 45 degrees to the plane, so 45 degrees, and that is called P. So it's going to accelerate in this direction, and the acceleration is 2. Okay, so let's resolve. So this is P cos 45 and P sine 45. So resolving horizontally, we've got F equals MA. So that's P cos 45 equals 10 kilograms, isn't it, times 2. So P is 20 divided by cos 45, which is 20 root 2 newtons. Or you could put it as 28.3. To 3 significant figures there. Let's jump into the next one. So a force of 20 newtons is applied to a box of mass M, causing the box to accelerate at 0.5 along a smooth horizontal plane. Given that the force is applied at 25 degrees to the plane, work out the value of m. So another nice straightforward one. I'll just draw this in. So that's m kilograms, mg, that's r. Force is at 25 degrees, and that force is 20 newtons, and A is 0.5. So I can resolve this. This will be horizontally 20 cos 25, and vertically will be 20 sine 25. Sorry about my writing there. Right, let's resolve this horizontally. F equals ma. So the horizontal force is 20 cos 25. The mass is m and A is 0.5. So m equals 36.3, not newtons, kilograms to 3 significant figures there. While these are exam questions, past exam questions, there are obviously more to them in the actual exams. These would just be like the part A's and so on for these exam questions. Anyway, let's jump into question 4. So we've got a parachutist of mass 80 kilograms is attached to a parachute by 2 lines with tension T, both with tension T. Parachute is falling with a constant velocity. They experiences resistance to motion due to air resistance equal to 1/4 of her weight. Show that the tension in each line T is 20 root 3g. So doing this vertically, each of these is going to give us T sine 60, and that's going to be twice off both cables there. We've got 80g going down, but we've also got air resistance. I'll do this one in red. So air resistance is also going to be up, and it's 1/4 her weight. So that's going to be 20. 20g, isn't it? Because it's her weight. So now we've got, if we resolve vertically, we've got 20g plus 2t sine 60, and that's equal to 80g. So 2t sine 60 is equal to 60g. T sine 60 is equal to 30g. Now divide by sine 60, and we do, well, 30 divided by sine 60 is 20 root 3g newtons, and that was what was required here. Okay, so nice easy question there. Let's look at the final example, or final question. So we've got a system of forces act upon a particle as shown. The resultant force on the particle is 2 root 3I plus 2j newtons. Calculate the magnitude of F1 and F2. So let me just pop this down here. So let's resolve some forces. The only one we can split up into its components is F2, and that would be a component down, F2 sine 30, and a horizontal component, F2 cos 30. And the reason is that this one's already going horizontally, so you can't split it up into horizontal and vertical because there's no vertical component. And this one is going vertically upwards, and again it has 0 horizontal components. There's nothing to split it up into. But now we can look at what's happening. So if I resolve vertically, then 12 minus f2 sine 30 must equal to 2, because it's 2 in the positive direction, so we're going up. And resolving horizontally, we've got f1 minus f2 cos 30 must be equal to 2 root 3. Okay, because that's 2 root 3 in the right direction, so this direction. So this one minus this one would equal that. So now we can use the first one to find f1. So f2 sine 30 is going to be equal to 10. Sine 30 is a half, so f2 is going to be equal to 20 newtons. Now substituting that in here, we get f1 minus 20 cos 30 equals 2 root 3. So f1 is 2 root 3 plus 20 cos 30, and that is 12 root 3 newtons. And that is the final answer there. I think you'll agree this is quite straightforward at the moment, but hopefully now you've understood the splitting a force up into its components. The next thing we're going to move on to is inclined planes. Okay, and that's where we split them up into components, but in a slightly different manner. So we don't necessarily split them up into horizontal and vertical in those ones. So stay tuned for the next video.